Hello everybody, it's Tech Compulsion here. In this video we're putting together a small form factor PC using some budget-friendly low-profile parts. This entire build is going to come in at 3.8 liters in volume and is going to feature a dedicated GPU and a built-in power supply. I actually bought these parts right before the RAM and SSD shortage hit, but I'm finally getting around to making this video. What I'm really trying to accomplish with this setup over the long haul is to discover whether a Windows PC running that brand new Xbox full screen experience can serve as a legitimate rival to the upcoming Steam machine. Right at the center of this build, we're rocking the Ryzen 5 7500F CPU. This processor is the perfect match for our GPU. With its Zen 4 architecture, 6 cores, 12 threads, and boost clocks up to 5 GHz, it gives the graphics card more than enough headroom to be fully utilized. The Ryzen 7500F gives this unit plenty of power, and it should be incredibly easy to cool given its efficient 65-watt TDP. For the motherboard, we're using the Gigabyte 8620i AX Mini-ITX. This is a budget-friendly AM5 board that supports one M.2 slot, 2 DDR5 DIMM slots, Wi-Fi 6E, and Bluetooth 5.3. For the CPU cooler, we're using the low-profile Noctua NHL9A AM5 Premium. At just 37mm tall, it will keep our temps under control while leaving plenty of clearance for that single-slot GPU we're planning to install later. Full disclosure, installing this cooler was one of the toughest parts of this entire build. First, I had to remove the motherboard's CPU stock retention clips. Next came the thermal paste. I went with a meticulous approach, a solid dab right in the center, followed by tiny dots on all 4 corners to guarantee 100% coverage across the die. But here's where it got tricky. To actually mount the cooler, I had to prop the motherboard up completely vertical. While balancing the board, I had to carefully hold the cooler in place to let the paste spread evenly, all while reaching around the back to secure the mounting screws from behind, working my way around each corner, tightening them down evenly for perfect fitment. Moving on to the RAM, we will be installing 2 GB sticks of Kingston Fury Beast. This 16 GB DDR5 kit supports AMD Expo, which allows it to run at 5200 MHz. For storage, we will be using 1TB Crucial P3 Plus M.2 SSD. This NVMe Gen 4 drive supports read speeds up to 5000 MB per second and write speeds up to 3600 MB per second. I believe this pairing is the perfect combo for a portable console-like build, especially since I'll be using it heavily for gaming and emulation. The Goodisory A09 case is a good choice for this project because it supports a flex ATX power supply, and with very little work, it can house a dedicated single-slot low-profile GPU. This means we don't have to worry about a bulky external power brick or relying on integrated graphics to run our games, making it the perfect console-like device that you could easily throw into a backpack. If we take a look at the back of the case, it features a single expansion slot. Even though this chassis wasn't originally designed for a dedicated graphics card, the release of the single-slot low-profile RTX 3050 makes a build like this possible. The components inside the case are definitely going to be crowded once the GPU is installed, but they should fit perfectly if I can keep the cabling under control. To start, I'm going to remove the screws holding the top panel so I can slide it off. Then I'll take out all the screws for the hard drive bay located underneath the top panel. Keeping in mind, these screws and the hard drive bay will not be reinstalled upon completion. Following that, I remove the front USB and audio header along with the power switch assembly from the case. This allowed me to unscrew and uninstall the front panel, which will give me the room I need to slide the motherboard into the case with ease. Before dropping the motherboard into the case, I made sure to connect the CPU cooler fan header to avoid trying to do it once the board was trapped inside the case. I also installed the motherboard's I/O shield onto the case beforehand, taking extra care to ensure the shield completely snapped into place. With a little bit of patience and effort, the motherboard slid right into the case. I had to apply some light pressure against the outer corner of the board to align the I/O panel cutouts while securing the 4 motherboard mounting screws. The power supply I picked for this build is the ENP7660B VK 600W non-modular Flex ATX from Velcase. Similar to the motherboard, having the case front panel removed made installing the power supply fairly simple. It allowed the cables to be fed right through the front opening so I could carefully slide the power supply into place. While a 600 power supply might seem overkill for a build like this, I wanted to make sure I use a high quality unit that would run whisper quiet in such a tight space. With both the motherboard and the PSU installed, it was time to make our power connections and tidy up the cables to leave enough room for the riser cable and GPU. First, I connected the 24-pin main ATX cable and then the 8-pin ATX 12-volt CPU power cable, making sure each connection was nice and snug. For good measure, I actually went back to double check the 8-pin connector since there wasn't enough room for my fingers to apply even pressure the first time. Next, I did a little cable management for the power supply cables and then moved on to a small modification to the case itself. The upcoming GPU installation required me to physically remove the outermost USB port on the case's front USB header. If left intact, the GPU would sit directly on top of the USB port, which would prevent the case top panel from closing flush. From there, I moved on to the power switch and the front USB header connections on the motherboard. Figuring out the power switch pinout took me a minute since there didn't seem to be much information in the manual that came with the motherboard, and all the labels on the PCB were not printed right next to the pins themselves. For reference, I'm putting a diagram of the front panel connections on the screen right now. With only the audio cable and the GPU connections left for the motherboard, I insulated the previously removed USB port with some electrical tape. I did this because the unused USB port is going to reside inside the case. Then I proceeded to reinstall the front panel onto the case. With the front panel secured, I reinstalled the power switch board, plugged in the front audio cable, and mounted the USB header board. Installing the header board was a bit of a challenge since the power supply cables were heavily in the way. I had to pay careful attention to ensure the sharp solder points on the back of the board didn't nick the power supply cables while I shimmed it into place. Once the header board was fully installed, I went one step further and added a layer of electrical tape over the pins to act as a protective barrier against the power supply cables leaning up against them. Now, moving on to the highly anticipated part of this build, the Yeston RTX 3050 6GB GPU. This is a low-profile single-slot card that is a slightly cut-down version of the original full-size 8GB model, but it still packs a major punch and is arguably the fastest consumer-focused GPU that this case can support. This GPU utilizes PCIe 4.0, just like our motherboard and the riser, which should allow us to take full advantage of the bandwidth of the RTX 3050. This final component installation was tricky, but thankfully not as difficult as the CPU cooler. Initially, I purchased a 5cm riser cable from LinkUp, however that turned out to be a poor choice because it stuck out too far, which would prevent the case from closing. I tried bending the cable to make it fit, but had no luck since it didn't have enough slack to fold over itself. Second, I bought a 10cm riser cable and tried my best to make it work. But this length yielded the same results. I couldn't fold it over enough neatly to make the GPU fit comfortably. I tried multiple times thinking that adjusting the angle of the bend might create a solid connection while letting the GPU sit properly, but it just wasn't happening. Finally, I landed on the perfect length, 15 centimeters. This extra length gave me enough slack to bend the cable comfortably and allowed the GPU to install beautifully in the case. I should also mention that during this final GPU installation, I had to completely reroute the power supply cables that were sitting on top of the SSD. This required me to uninstall and reinstall the front panel yet again just to manage the wires. Some of the PSU cables were routed tightly along the edge of the case while others were folded flat to make room for the precise bends needed for the riser and the GPU to install nicely. Now looking at the completed build, we can see exactly how everything came together. As expected, there is plenty of clearance between the CPU cooler and the GPU backplate. None of the components interfere with closing up the case, and the side ventilation holes aren't completely blocked, leaving enough room for fresh air to feed into the system. Best of all, nothing is forcing the chassis to bulge out due to clearance issues. As you can see, I've placed the other two riser cables that I tried using earlier near the case to illustrate their bending limitations. Overall, I'm incredibly impressed with this case and its ability to house all of these components. I know there are plenty of other small form factor Mini-ITX cases out there, but I chose this one because it was the absolute smallest enclosure I could find that could fit these specific components while still being able to lay horizontally. Not to mention, it cost merely a fraction of those other boutique cases I was originally considering. Moving on to the fun part, gaming. Here I am playing Mortal Kombat 1 at 1440p, high preset, DLSS balanced, upscaling sharpness at 20, and the experimental 60 FPS mode set to off. There are occasional 1 to 2 frame drops during fighting, but it's imperceptible, making it pretty much a locked 60 FPS experience. The same thoughts apply to the game's built-in benchmark. As you can see, there is no sound of the gameplay. This is because I am measuring the noise coming off of the case during gameplay to report on it later. The game looks excellent even though it does not have ray tracing features turned on. For Doom the Dark Ages, I am playing at 1080p, handheld preset, DLSS balanced, and the texture pool slider set to the minimum. Asset popping may be noticeable if you are sensitive to that, but I think these settings provide a very respectable presentation and it averages 61 FPS. I would say this is similar if not better performance than an Xbox Series S console. Next, I played Fortnite at 1440p and DLSS set to performance. I also had shadows set to medium, view distance set to far, and everything else on low or off. I don't think you can go wrong with DLSS balanced or performance due to the art style. The game plays flawlessly and looks surprisingly well in low settings. On DLSS performance, the game was averaging 135 FPS and on balance it was close to 120. Playing Forza Horizon 5 was awesome on this little PC. I was able to play at a native 1440p high preset. The game feels very smooth and looks amazing. I was averaging 104 FPS during normal gameplay and 85 in the benchmark. Halo Infinite was another game that surprised me. At 1080p low preset with texture quality set to medium, I was averaging 90 FPS during 4v4 matches and 84 FPS during big team battle. Both small and big maps played well and characters still looked very good. I also managed to run the game at 1440p with an average of 65 FPS, but I honestly couldn't see much of a difference in sharpness. However, I could definitely feel the difference in smoothness while playing at 1080p over 1440p. Shadow of the Tomb Raider was another game tested. This game ran at 1440p high preset and DLSS on. The game's benchmark looked fantastic in both DLSS quality or balanced. I could go either way, especially if I have a display that supports variable refresh. The game managed an average of 68 FPS in DLSS balanced and 60 FPS in DLSS quality. Call of Duty Black Ops 7 was the last game I played. At 1440p basic preset and DLSS set to performance at 50% sharpness, my mind was blown. The game is very playable in this setup. Both Benchmark and Zombies had very respectable numbers. The Benchmark had an average FPS of 93. In Zombies, I averaged 78 FPS. I occasionally would see dips below 60, but it didn't interrupt the gameplay at all. All in all, I'm very happy with this tiny console-like PC. It has very good performance for the form factor, and it allows me to have a PC that I could literally carry anywhere with me. I've been wanting to build something like this for a very long time because all of my friends are gamers and I wanted to have a system that I could bring over to LAN parties or emulate split-screen games. I did not want to be locked to one ecosystem as all of my friends are into different games and platforms. The possibilities are endless with this setup. That being said, this build is not perfect. The CPU and GPU temps run fairly high when the ambient temperature is high. I saw temps as high as 88°C for the CPU and 83°C for the GPU. During those instances, I noticed that the power supply fan would kick in, making the case fairly loud. I noticed that while idle, the PC would sit around 51 dB, which is not bad. During gaming without the power supply fan running, it would hover around 55 dB, which was tolerable, but when the fans kicked in, it would go as high as 65 dB, which was very loud. I believe I can fix this with a modest undervolt for both the CPU and the GPU. Another thing I learned after this build was complete is that the motherboard I picked does not support CPU undervolting natively, so I will need to use a third-party tool to accomplish this. I plan to make a follow-up video once I'm able to successfully undervolt the system. I will probably rerun some of the games seen today to see how they perform, and I will also run new ones. If you have any games you'd like to see, let me know in the comments below. I have many more videos planned for this build as I am still trying to set up the Xbox full screen experience. If you enjoyed the content, consider liking and subscribing. Catch you in the next one.